Inequality, and then I go one's bigger than the other. Out. Right?
All right, welcome back. I hope you all enjoyed your Thanksgiving. So before we left for Thanksgiving break, we were talking about, we were talking about point slope form and standard form of equations and lines. That will come important once we jump into December. Specifically, the standard form one will show up a little bit more, and specifically graphing it and stuff like that. And we'll talk about some stuff later in December. But for this week, we're going to talk about inequalities and what an inequality is. And so you've probably been introduced to inequalities. I think 8th grade is when you're introduced to them, if not a little bit earlier, if not used in 7th grade. But we're going to talk about solving inequalities and graphing inequalities this week. So that's what Friday assessment will be on, as long as there's no snow, blizzards, or anything like that like we had before Thanksgiving. So that's the goal for this week, is talking about inequalities. But before we talk about inequalities, we need to figure out, what does this word inequality mean? So when I say the word inequality, what do you think of? What does that mean to you?
Big word. One, like when you have charts, the bar charts where they go up, one being way bigger than the other. Because
Okay.
they're unequal.
Unequal, one being larger than the other? Not equal? Okay.
Treat someone like dirt.
Treat someone like dirt? Okay. So
Unequal rights.
unequal rights? Good. Okay. So no, those are all good ways to think about it. Not necessarily good, but it's all ways to help you remember what inequality means. So inequality means, as Jim said it in the most simplest terms, unequal. And so we just look at it. We have the word equality, and we throw inequality in there, saying it's not equal. So anytime we have two things that are in an inequality, we are going to have one that's either going to be larger or smaller than the other. So we're going to have two sides. One side's going to be larger, one side's going to be smaller. And so when we talk about an inequality, we're typically talking about one that involves a variable. So we're going to involve seeing a variable and a number and seeing how is that number larger than the other or smaller than the other number, and we'll talk about how to graph that and solve them just like we were with equations. So we can create equations, or we can create inequalities just as we would with an equation, but rather than having an equal sign, we're going to have an inequality. And so we have a couple of inequalities that you've probably been introduced to before. These little symbols.
Greater than or equal to that.
So we have two types of symbols, or I guess 4 types of symbols. But we have greater than and less than, and then greater than the equal to and less than the equal to. And really it depends on which side your variable is, which determines whether it's a greater than or less than. I'm just going to put my variables on all of these on the left side. And then you would have some other number on the other side, like 7 or 4 or 8 or 2. It doesn't really matter. We'll say negative. We'll throw a negative number on there. So for example, this one would be x is less than 7, x is less than or equal to 4, x is greater than 8, x is less than or greater than or equal to -2. So anytime it has that bar underneath, that's less than or equal to or greater than or equal to. And that's something we'll want to pay attention to. Because being less than 7, what's a number that's less than 7?
6.
6. What's the number that's less than or equal to 7 then?
-1.
-1. But 7 is also an answer for possible answers. We have an infinite number of answers because there's an infinite number of numbers that are less than 7, but there's also one extra number that's less than or equal to 7 as well, because you have to include that equal to.
Jarvis, can you solve it?
What?
Are you recording this?
Yes, I am. All right. So when we deal with inequalities, we often like to graph our solution. All right. So we often like to graph our solution because, once again, like I said, these solutions to these answers, there's not just one number. It's not just 7. It's not just 4. It's not just 2. It's a large array of numbers. We can have a whole group or a whole amount of numbers that might meet this inequality. So for example, when I said what's the number less than 7, some of you said 6, some of you said -2, some of you said -1. There's a bunch of numbers. And so we graph these answers on a number line. So I'm going to graph less than 7. So when graphing on a number line, you might have been introduced to this before, you might not have. Graphing inequalities on a number line. I can't remember if this is a standard in previous class. You need to find where that number is. So I see less than 7. 7 is over there. And so all the numbers that are less than 7, that's going to be to the left of my number. 6, 5, 4. These are all going to be numbers that are less than 7.
Oh, yeah, we did this.
Done it before?
Oh, yeah.
Yeah.
That weird circle.
Good, good. So,
Then we have to bold it for the, oh, yeah, greater than 3.
good, good. Glad you remember this. So if we have something where it's greater than or equal to, so let's say greater than or equal to -2, I'll put that in red. So if I'm greater than or equal to -2, once again I have to find -2. But rather than being an open circle, because I'm equal to, I want to include that number. So to show that I'm including that number, I'm going to fill in this line, or fill in that circle. So an open circle is strictly less than or strictly greater than. A filled in circle is greater than or equal to or less than or equal to. And then I need to go greater than -2, which is any number larger than -2. Does this seem familiar?
Yes.
Yeah. Awesome. Okay, that'll make my life easier. Quick strategy. If your variable is on the left of your inequality, like all of these ones are, if you notice, the inequality, if you think of it like an arrow, it points in the direction that your line should go. So less than points to the left. Less than or equal to points to the left. Greater than points to the right. And so your arrow will go to the right.
Said that.
But the thing to make sure is it only works if your inequality is on the left side. And so if your inequality is on the left side, it'll be right. If it's on the right side, then it will be opposite what you think. So with inequalities, with graphing these solutions or graphing these inequalities, we need to, sometimes we have inequalities that's like an equation, and we need to solve for that variable. We need to solve for that group of solutions. What's the answer to that inequality? Luckily, and this once again might have been something you've been introduced to before, solving inequalities is just like solving equations. We can use the exact same step, pretend it's like an equal sign, and you do the same thing. So if I were to solve this, once again, I just need to get x by itself, just as I would with an equation. So I need to get rid of that 7. So right now I have a positive 7, so what would be my inverse operation to get rid of that 7? Subtract. And if I do it to one side, I need to do it to the other. So if I subtract 7, that leaves me with x is greater than 5. Now that I have my solution, I need to graph it on my number line. So x is greater than 5, I find 5. Am I going to use an open circle or filled in circle? Open circle, because I'm strictly greater than. And then greater than gets to the right. And now I'll do my solution. So we can also check our solutions, or we can prove our solution is true. In order to check, we just need to find one number that falls into that solution, one number that falls in that range, and plug it in to see if it works. So what's a number greater than 5? So those are all good numbers. I like to use the easiest one, so I'm just going to use 6. I could use like 16 billion and a half or something like that, but why use that large number when I can just use an easy one? So I'm just going to plug 6 in. So 6 plus 7 is greater than 12. Let's see if this works. 6 plus 7 is 13. Oh wow, 13 is greater than 12. So it's correct. And so anytime if you want to check your solution, just pick a number that falls within that range, plug it back in for x. If it works, it works. If it doesn't work, then we probably messed up somewhere. Are we okay with this? Have we done this before? Solving inequalities as well? Okay, cool. Most of this will be practice and that'll be. So let's look at this next one. We have negative 6x plus 4 is less than 28. What would you do on this one? How would you go about that? So I believe White, you said get rid of the 4 first. So we want a minus 4. Okay. So that gives me negative 6x is less than 28 minus 4 gives me 24. What now? We need to get rid of this negative 6. So right now it's being multiplied, so I'll divide. So that gives me x is less than 20, negative 4. 24 divided by negative 6 is negative 4. So we can graph this once again. I have x is less than negative 4. Negative 4 right here, less than points me to the left direction. Once again, I just want to check it just to make sure if it's right. So I want to use a number that's less than negative 4. I'll just use negative 5 because that's easy. So negative 6 times negative 5 plus 4 is less than 28. Negative 6 times negative 5 will give me a positive 30 plus 4 is less than 28. 34 less than. Wait a minute. Is that right?
Wait a minute.
Is 34 less than 28?
Who are you? Oh my God, Dad!
So what happened here?
Reverse
Did
psychology.
something wrong? How would we have to change the inequality to make it right? It would have to be flipped. We would have to have 34 greater than 28, which means x would have to be greater than negative 4, which would go the other direction. Now, why do we think that's true?
Because 34 is not less than 28.
The inequalities, solving inequalities is exactly the same as solving an equation. We can do all those same steps. There's one thing we have to watch out for though. Anytime you're multiplying or dividing by a negative number, it flips our inequality. So when we divide it by negative 6, it changes from a negative 6x to a positive x, and you need to flip your inequality at that moment. So this is actually x is greater than negative 4. So it only works when multiplying or dividing by negatives. That's the only time it ever happens, but we need to be vigilant for that. We need to watch out. And that's why checking your answer is always a nice little habit. Just in case if you multiplied or divided by a negative and you didn't catch it, check your answer just to make sure it's right, and if it works out, then you're good. If not, check back to see if you accidentally multiplied or divided by a negative and see if you forgot to switch your sign. That's just something we'll have to stay on top of. Just make sure to flip the sign. Other than that, so once again, with dealing with these, it's just like solving an equation. So we just have to think back, what are some of those rules, what are some of the strategies we use when solving equations? So distributing, combining like terms, we have to think through those as well. So we have negative 7y minus quantity 6 minus 2y is greater than or equal to 14. Now looking at this problem, what would you do first in order to solve this?
Let's distribute.
Distribute. But I don't really have a number in front of that. What would I distribute?
1.
If I pretend that's a 1, that's really a negative 1, so I'm going to distribute the negative 1 in there. So I have 7y, or negative 7y. I'm distributing negative 1 into each part of my parentheses. So negative 1 times 6 is negative 6. Negative 1 times negative 2y. It's going to be a positive 2y, and that's greater than or equal to 14. Okay. What would you do next?
Combine terms.
We just distributed our negative 1 into each of these. So now we need to combine like terms. So I have a negative 7y and a 2y. They both have y, so they're like terms. So negative 7 plus 2 will give me negative 5. So negative 5y minus 6 is less or greater than or equal to 14. Okay. What now?
Division.
So before we can divide by the coefficient in front of our y, we need to get rid of those constants.
So plus 6.
So we'll have to add 6. Always want to get rid of your constant first. That leaves us with negative 5y is greater than or equal to 14 plus 6, which is 20. All right, we almost have y by itself. What's our last step?
Division.
Division. So we're dividing by 5y. So that gives me y. And then 20 divided by 5y is,
Less or equal to.
that's negative 4. But if we're dividing by a negative, what do we need to make sure to do?
Oh yeah, go the other way.
Flip the sign. So if my y was greater than or equal to first, now it's less than or equal to negative 4. Last step, find negative 4 on my line. Negative 4 is right here. I'm equal to, so I'm going to fill it in. And then if I'm less than negative 4, I will go to my left. So once again, we're just using those same strategies, the same skills we learned when solving equations. We just now have to think about the inequality. Really, the only thing changed with these is remembering to flip the sign and remembering how to graph. Once again, you can check your answer just to make sure you're right by plugging in a number that's less than 4, so like negative 5, and filling that out. And if it works, you're good. Checking isn't required. It's just a helpful strategy just to make sure in case you're worried that you got the wrong answer. So you have 2 more on the back of your paper that I want you to take a try at. So once again, remember, we're going to need to combine like terms. We're going to need to distribute. Remember to watch out for those that multiplying or dividing by a negative. You have to change your sign. So take a moment, see if you can graph these solutions. Okay, so hopefully you were able to get through these on your own. If not, that's okay.
I did.
So let's talk about what we did on this first one. So how do you solve it? What do you do?
Distributing.
So we have to distribute in first. So that 4 times 2 and 4 times negative x gives us, 8 minus 4x is less than negative 3x plus 5. Where do we go with from here?
You minus, add 4x to the other side.
So we can add it to either side. It doesn't really matter if we're adding 4x over or adding 3x over. It doesn't change your problem. So negative 4x plus 3x gives you negative 1x. So I wrote plus, not minus. And that's less than 5. We need to get that 8 over to the other side. And so we have negative 1x, because your 8's cancel out. 5 minus 8, what's that? Negative 3. Last step.
Since you did that again.
So I have to divide by negative 1, divide by negative 1. But if we divide by a negative, we need to flip our sign. So we get x is greater than 3. Find 3. Why is it an open circle?
Because it's not equal to.
Because we're just less than or just greater than. We're not equal to. We don't have that line already. What did you do on the second one?
Same thing.
Okay, so we distribute first.
Then I did the crossing thingy where you like add or subtract the side. And then I did the.
So what did you move to the other side?
I moved I added 3.
Alright, so we can add 3x, which will combine with our negative 2x.
Equal 1 minus 6 to 15. Got 9. And I divided by 1.
So if you divide by 1, change your answer.
Yeah, I switched everything.
So divided by 1, it won't, 9 divided by 1 won't change. Your answer question doesn't.
Yeah, the circle.
So if we notice on this one, we have x on the right side. So typically we like to write x on the left side because it points us in the direction we want to go. And so we can rewrite this just as x is less than 9. If you want to switch your x to the other side, that's fine. You just need to make sure to switch the sign accordingly. And so if x is less than 9, I can find 9. And because I'm less than or equal to, I'll shade it in. And then less than 9 points to the left. Are we okay with this? Do we have any questions on these at the moment? So, you have one more problem. What do you notice about this one and why is it different? What was that why? It has fractions. What else?
Letters. It takes up the entire space of the page.
Parentheses. If we look, equal, we don't have an inequality on this one. We have an equal sign. So with this problem, we're going to talk about how to graph an equals on a number when it's 1. But first, we'll have to solve it. So this will be a good refresher with parentheses and a good challenge problem, and it also have an equal. So we won't have to worry about the inequalities with this one, which is nice. So, looking at this, we have 2 parentheses. So we need to distribute in order to get rid of those parentheses. So I'm going to distribute my 1/3 into both of these. So that'll be 1/3 r, and then I'll have to do 1/3 times -5. So if I think about it, multiplying fractions, 1/3 times 5. 5 isn't a fraction, but I can turn it into 1 just by putting it over 1. So multiplying fractions, you multiply straight across, top by top, bottom by bottom. So 1 times 5 is 5, 3 times 1 is 3, so that gives me 5/3. Now, we have a second set of parentheses. So we're going to have to multiply again. This time we're multiplying by -2/5. So I have to distribute that in. So we'll have to do -2/5 times 7/2. What do you notice about these fractions? So I have a 2 in both of them. A 2 in the top and a 2 in the bottom. If I have the same number in the top and the bottom, I can cancel that. So if I cancel that out, I'm just left with a negative. So this is negative times 7, which is -7. 2 times, or 5, I'm sorry, 5 times, cancel that number is just 5. So that's -7/5. And then times our -2/5 times -r. Negative times a negative gives us a positive, so the positive 2/5. So we have to deal with a little bit of fractions so far, but we're hanging in there. We're doing okay. So once again, we always like to get those variables on the same side. So which side do you want to get your variables on? Your left or right? Left side. Okay. So we need to move this -2 or this positive 2/5 over to our other side. So I'm going to subtract it to write out the positive number. But now we have to think. 1/3 r minus 2/5 r equals. So I'll go back over here where my other fraction work was. So that's 1/3 minus 2/5. Adding or subtracting fractions, what do we need? So anytime we're adding or subtracting fractions, we need a common denominator. So how can we find a common denominator with 3 and 5? So anytime you're looking for a common denominator, the easiest way to go, just multiply these 2 numbers together. So we're going to make both of these 15. But if I change this to a 15, I multiplied it by 5. In order to stay 1/3, in order to not change that number, if I multiply the bottom by 5, I need to multiply that top number by 5 as well. So what's 1 times 5? Now, if I multiply this number by 3, and I want to stay consistent, I need to multiply the top by 3. So 2 times 3 will give me 6. So that's 5/15 minus 6/15. So what would that leave me with? What was that? Negative 1/15. So that's negative 1/15 r 15 minus 5 over 3 plus 2 over 5. Nope, sorry, that's minus 5 over 3 equals negative 7 over 5. Where would you go from here? How can we get r by itself?
Plus 5 to the other side.
And you get that 5/3 to the other side. We're going to add 5/3. But adding 5/3, we have to do a little bit more work with some fractions.
15 over negative 2. No, negative 2 over 15.
So negative 7/5 plus 5/3. Once again, we need like terms in order to add them. Just like when we did with subtraction. So 5 and 3, once again we can use 15, multiply those numbers together. But that means I also need to multiply this by 3 if I multiply my bottom. So negative 7 times 3 is negative 21. I multiply 3 by 5 to get 15. So I have to multiply the numerator of my fraction by 5. 25. Negative 21 plus 25. 4. So 4 over 15. So we have negative 1/15 r equals 4/15. We're almost done. We're almost there. My last step.
Oh, that's right.
Divide. So I'm going to divide by negative 1/15. Divide by negative 1/15. So if you think, what's 4/15 divided by negative 1/15? Dividing fractions. You want to ask why? Split the second and multiply. So dividing fractions, don't ask why. Just split the second and multiply. So that means we split the second, we really have 15 over negative 1. What do you notice about these fractions?
We can,
So I have a 15 in my denominator, 15 in my numerator.
and then be like, oh.
So 4 over negative 1, that's the same as just negative 4, or negative 4 over 1. And so we found r equals negative 4. So it took a bit of work, a lot of fractions, but that's good to be able to remember how to deal with fractions. Because on your state test, they're probably going to throw some fractions at you too. So because this wasn't an inequality, because it was just equals, with graphing this, we just need to find negative 4. Should I fill in this circle or close this circle?
Neither.
Fill it in because I want to be equal to it, so I want to exclude it. And And then because I'm not greater than or less than, I don't need to go anywhere. I'm not going to go below or not going to go above. It's just a circle at -4. So we're going to continue to work with inequalities tomorrow, and then we're going to graph them on Wednesday. What? Yes.
Whoa. I'm going to show you if I like got.
I hope it.